Okay, the quiz for today was list the 5 basic functions, do a quick sketch, and say whether the function is one-to-one. And hopefully with some explanation, because we really want explanation here. Okay, incidentally, here's my email address. It's dsmith@vhcc.edu. In case you can't find it, it's on my syllabus in Canvas. And you can find it through the VHCC website, but that can be hard to navigate. Okay, so which of the basic functions are one-to-one? Ask people to give me examples. Some say, okay, the cubing function. Yep, that's one-to-one. Here's a graph of the cubing function. Incidentally, this dotted line graph is a graph of the reciprocal function that I kind of mentioned, but I'm not going to worry about that except, well, yeah, we will, just a little bit. So, okay, so here's your basic cubing function, and we can see that whatever your y value is, whether it's up here, down here, anywhere up here, anywhere down here, there's a point on the graph that has that y value. So that there's a value of x that will give you that y value. It's important to understand that. Okay. Also, there's only one in each case. No matter where you are on the y-axis, there's only one point on the graph that corresponds to that y value, which is what makes the function one-to-one. Now that comes down to the horizontal line test. Horizontal line test is great, but you need to understand why it's the horizontal line test. And it's again because if a function passes the horizontal line test, so no horizontal line crosses the graph more than once, then it's one-to-one. And that is again because any horizontal line has a y value that's the same everywhere on the line, and if it only hits the graph one time, then there's only one x value associated with that y value. And that's the idea of one-to-one. It's important because you can invert this function. You can find the inverse function, which is the cube root function, or the x to the 1/3 function. You don't need to know that. You don't need to know how to invert it, but I'll just mention it. And this works because if you switch the x and the y values, and you can do that, with a basic function, you can switch the x and y columns, and you get a set of points that follows this pattern, okay? And this is a function. Okay? There's only one y value for every x value that passes the vertical line test because, of course, when you invert things, vertical lines become horizontal lines in a way that we'll talk about in more detail later. So just anticipating this, one-to-one functions are very easy to deal with when we're inverting them. We don't have to do anything fancy to find the inverse function. Okay, and that's coming up soon. Okay, so I mentioned it now. Then somebody said the exponential function. Well, the same is true of the exponential function. Now, of course, you need to know immediately from the name what the graph looks like. You did the matching with the graph, and people did quite well on that. You don't do the homework and then forget it immediately. And of course, as an instructor, I'm going to kind of reinforce these important points. So you're less likely to forget it. So anyway, you've got to know what the graph of the basic exponential function looks like. And I did mention that people need to be just a little better on doing the graphs of the basic functions and evaluating those functions. Okay, now we have the squaring function. People mentioned the basic squaring function, and yeah, okay, the squaring function has a graph that looks like this. And for any y value, now there are 2 x values, aren't there? So we intersect this graph in 2 points with this horizontal line, meaning that there are 2 points on the graph that have the y coordinate for that horizontal line. So this is not one-to-one. If you invert it, you get something that looks like this, and it doesn't pass the vertical line test. There's not just one y value for every given x value. So you got to do something to get the inverse function. The basic reciprocal graph, I think somebody suggested that one was maybe not one-to-one, but it is one-to-one. There's no place on the y-axis, there's no y value that gives you more than one x value, okay? In other words, it passes the horizontal line test. Again, you have to know what the horizontal line test means in order to really understand everything, but there it is, okay? Okay, Now, down here, we have the basic reciprocal square function, and again, just about any y value in the range of this function is going to have two x values. So there we have it. Then we have just some simple function notation. And one question not so simple, I'm going to talk about it just a little. But f of negative 1/2 equals what? Well, f of x equals x cubed for the basic cubing function. F of negative 1/2, you replace x by negative 1/2, you get negative 1/2 cubed, and that gives you negative 1/8. F of 3/2 will be 3/2 cubed, which is 27/8, just do the arithmetic. And skip this for a second, f of g of x, where g of x is a basic reciprocal function. Well, first of all, f of g of x, you're replacing x with g of x. So f of g of x is g of x cubed. And now, if g of x is a basic reciprocal function, that's going to be 1 over x quantity cubed, which is then 1 just over x cubed. So those questions are fairly straightforward. Now let's talk a little bit about the value of x when f of x equals 2. Well, you have the basic cubing function, and I'm just going to do it in the first quadrant right here because f of x equals 2 means that the y value is 2, which is more than 1. So we have 2, 1, 1/2, we have 8, 4, 2, 1, and there's 1/2 and 1/4. Okay, so we have points on the graph. And a graph that looks like this. Now this is the extended basic squaring function. And of course the value 1 goes with x equals 1. What about the value 2? Now we're saying for f of x equals 2, right? Let's be careful, let's be clear. So at x equals 1, we have the point 1, 1. Okay? Meaning that x is 1 and y is 1, y equals f of x, and we could write y equals f of x equals x cubed. Okay? X is 1, and f of x, which is the y value, is 1 at this point. Okay? Here's the point 2, 8. X equals 2. F of x is 8. Now, what about the point where f of x is 2? Well, let's see, f of x is 1 here, it's 8 here. Well, f of x is 2 at the point that's horizontally across from the x equals 2 point. So we can estimate the value of x when f of x equals 2. So let's just say this point is maybe 1.3. Okay, so if this point is approximately 1.32, I can say that the value of x when f of x equals 2 is about 1.3. Now that's a little bit high, but it's closer to 1.3 than it is to 1.2, so that's not really a bad estimate. Okay? Now you can calculate it by doing a cube root, but we haven't talked about that, and you might not know about that. The point is that when you have a graph of one of these functions, you can answer questions like this. The value of x when f of x equals 2. And there's another way to state this result. Get a good color here. Okay, I can say this. The solution to the equation f of x equals 2 is about x equals 1.3. And we get that from the graph. So if we wanted to solve the equation f of x equals 4, I'd say, well, y is f of x. We come across here from 4, we come down here. And it looks like we get something about 1.4. Okay? Maybe 1.5. So the solution to the equation f of x equals 4 might be around 1.5 if our graph is accurate and if we believe our graph. Whether we have a completely accurate graph or not, though, it's important to see how the graph relates to the solution of an equation. We'll be saying more about that later.